Now let's create this crankshaft. So first we'll enter into here new part design. Let's say OK. So to create this crankshaft, we are going to start from this. So just we'll create this off section and we'll make it here revolve boss. For example, on the front plane, we'll create this off section profile like this. Up to here we'll close it. Dimension for this we are having. So here diameter we are having 32. So we need to provide here half dimension. Then this we are having 72. So we will give here 72 by 2. Next to that, this width we are having 38. So this we need here 38. Then this width we are having here 80. Let's give that width of 80. Exit sketch, isometric. We will go here with revolve boss with reference to this as central axis. Let's say OK. Then next to that, we are having with width of 15 mm with this shape. So to create that shape, we will go for sketch on this face, make it normal. We need here one circle. Relation between origin point to this point, we need vertical relation. Dimension between origin point to the center point we are having here vertically, as you can see here we are having 44. Then dimension for this we are having radius of 36. Let's give 36 into 2 as diameter. Later we will display as radius. Then one line we want like this. Relation between this circle to line, by holding control, if we select multiple elements, we are able to apply relation between the two. Then to make it mirror, we will create one reference construction line. We need to make mirror this line with reference to the central axis. Let's say OK. Then by using 3-point arc, we will create one curve like this. Then dimension for curve we are having radius of 80. Then angle between line to line, we are having here inclination of 33 degrees. Now if we try to move this curve is able to move freely. As you can see here, this curve center point is not fixed. So that point exactly it should start from origin point. So we'll apply relation between origin to that point we need here, coincident like this. Then let's go for trim. We'll trim these unwanted elements. So once if I trim this, again profile is coming underdefined. As you can see, tangency relation missing here. Let's separate relation between these two. We need tangent. Then exit sketch, make it isometric. We need to make this extruded boss width of 15 mm. Let's give this width of 15 and say OK. Again next to that, exactly at center point of this, we are having diameter of 54. It should be make extruded boss of 46. Here we'll go for sketch, make it normal. One circle we need exactly center point of this. So exactly from here with the diameter of 54. Exit sketch, isometric. We'll make this extruded boss. Total width we need here 46. Let's make it here 46 and say OK. Then later to that same step we need to repeat. Again we will go for sketch here, make it normal. Instead of drawing this entire shape, just we can use convert entitles. Then we will select this entire part. So this again this entire curvature we want. Let's say OK. Exit workbench. Then we will make again extruded boss. We need here same width of 15 mm. So let's give this width of 15. Let's say OK. Again next to that, with same diameter of 72, we need to make this extruded boss of 38. Here we will go for sketch. Already we have created circle, but here we are not able to get. In that conditions, we can change here display style as this hidden lines. So convert entitles, we'll convert this. OK. Then exit sketch. That should be make extrude boss of again 38. Let's say OK. Then again next to that same shape with 15 mm. Here we will go for sketch, make it normal. Again we will go for convert entitles. We need to convert this entire outer shape. Done. Exit sketch. we'll make this extrude boss of 15. Let's say OK. Then next to that, as you can see here, this part it should be in reverse direction. So whatever the shape we are having here, this should be in reverse direction. So just I will delete this. We need to make it in reverse direction. This sketch also we will delete. So I'll change here display style as like this. So on this face, we need same shape in reverse orientation. So in this case, we need to create again. So just I will create in reverse order. For that, I will go here one circle somewhere here like this. Then relation between origin point to this point, we need vertical relation. Dimension between point to point vertically we are having 44. Dimension for this we are having here radius of 36. So 36 into 2 I will give. We will convert into display as radius. Then one more circle or one line we want somewhere here with inclination. So just we will create one inclined line like this. Then to make mirror, here only I will create one construction line vertically. Then relation between these two, we need here tangent. This line we will make mirror with reference to this mirror about this. Let's say OK. Then one 3-point arc from point to point in this direction. Dimension for curve we are having radius of 80. Already we know this. Then angle between these two we need here 33 degrees. Then center point of this curvature, it should be exactly on this origin point. So these 2 points will make it here coincident. Let's make it coincident. Let's go for trim. We'll trim these unwanted elements. Then relation between these two we need here tangency. Done. Then again exit sketch. Make it isometric. We need to make this extrude boss of same 15. Let's say OK. Then next to that, we are having here same this circle with a diameter of 54. So here we'll go for sketch, make it normal. We need one circle exactly center of this curvature. So if I go here, we'll get here one center point with a diameter of 54. Exit sketch, isometric will make this extrude boss. So this should be same extrude boss of 46 equal to this. We'll make it here 46. Let's say OK. Then next to that again same shape we need in reverse direction only. Again here we will go for sketch. Then we will go for convert entitles. We need to convert this one in orientation will be reverse. Just we will convert that. Then OK. Again we will make this extrude boss of 15. Let's say OK. So up to here done. Again same center circle with same this extrude boss of 38. We'll go for sketch. Make it normal. So we'll convert here display style as shading with hidden elements. We'll convert this center circle. Done. Then isometric extrude boss of center one we need here 38. Let's make this extrude boss of 38. Let's say OK. Then this up to here we have done. Again here also we need in reverse orientation only. On this face sketch, make it normal. Same shape we want. So just we will convert this invert orientation like this. We'll make this extrude boss of 15. Then again here we'll go for sketch. Make it normal. At this position we need this circle upside. So let's convert entitle for this. OK. Exit sketch. We'll make this extrude boss. So this again we need to make this same 46. OK. Then next to that, as you can see here, total we have completed 5. So this 4 plus 5. Again same one more also we need in same orientation. So let's make it with same shape. So this to this again here sketch, make it normal. Same orientation again we wanted. So just we'll convert this. we'll make this extrude boss of 15. Okay. Then later to that we need this center part. Again here sketch, make it normal. So we will convert entitles this entire like center circle. We'll make this extrude boss of center 138. Just give 38. Say okay. Again we will go for sketch here. Make it normal. So here we need reverse orientation 2 profiles. So we'll go for convert entitles. We need to convert this shape. This will make this extrude boss of 15. Okay. Then circle we need downside. So again on this face we'll go for sketch. Make it normal. We need convert entitle for only this center circle. Let's say okay. Exit sketch. We'll make this extrude boss. So same this downside we are having 46. Let's give dimension for this 46. Then again on this face we'll go for sketch. Make it normal. Again I'll convert entitles with this shape. Okay, exit sketch. Then again extrude boss of we need 15. Let's say okay. Then one more here, same center circle with a diameter of 72. Let's convert this center circle. Let's say okay. Then exit sketch, we need to make this extrude boss of same this dimension we are having for the center circle. As we can see 38 we need to make extrude boss. Okay. At the end we are having here this one more circle with a diameter of 144. So to create these two steps you can draw off section, we can make it here revolve bus also, or else separately we can do pad and pad. So again here just we'll go for sketch, make it normal. I'll create one circle exactly from origin with a diameter of, as we can see, outer diameter 144 we want. Exit sketch, then extrude boss. This should be extrude boss of 15 mm. Let's give this extrude boss of 15. Let's say okay. Now entire display style will convert into shading with edges like this. Then later to that we are having here fillets with radius of 3 for all these sharp edges. So let's apply fillet with radius of 3 mm for all these edges. So let me select this one by one. As you can see from here we need to start again here. So only this, then this, then here also we need to select on both sides. So let me select all these edges. We'll select all on one side. Later we'll go for one more side at a time. Just we can use this all concave 10 edges. All will be selected at a time like this. Then we need here only radius of 3 mm, radius 3. Let's say okay. Like this properly fillet will be applied for all at a time. Then here we are having diameter of 10, 8 holes exactly on position of diameter 110 circle. It means we need to create hole. We'll go for hole wizard. So to create hole with our own parameters, we'll go for legacy hole with a diameter of 10. Depth should be up to next. Position should be exactly on this face. So somewhere here, make it normal. Then escape. We need here one circle. It should be for construction. It is like BCD or PCD circle. BCD stands for base circle diameter. PCD stands for pitch circle diameter. Now this circle we need 110. Add relation. This point should be exactly on this construction circle. Make it here coincident. Then as you can see, total we need here 8 holes. So directly we can apply relation between center point to this. We can make it horizontal or vertical, any one. Let's say OK. So one hole we have created here. By using this, we need to create duplicate holes of total 8. We can go directly here, circular pattern. Direction is with reference to this. Total we need here only 8. Let's say OK. So in this way, you can create this crankshaft. So then just we'll change some color for this. We'll go here with appearance for this part. Let me apply some color for this. So just I'll apply some different color for this like this. And let's say OK. Now let's create this piston in SolidWorks. So just we will enter into here new part. Let's say OK. For example, on the front plane, just I'll go for a sketch. I am going to create only this half part. So for that, just I'll go for line. Exactly from here, I'll start one vertical line, then one horizontal line straight to that, again one more vertical line. As you can see, one curve we are having. So we'll go forward and come backward. You will get curvature here like this, up to here somewhere. Then one vertical line, close this like this. Then we will go here with relation between this point to this line. We need here coincident. Let's apply coincident. Then we will go for dimension. As you can see, dimension for this inside profile we are having diameter of 76. From this to this inside profile, diameter of 76. As we created only half profile, we need to give by 2. Then for outer one we are having with a diameter of 85. So from this origin to this end we are having 85 by 2 like this. Then total height we are having here 90. For this we are having height of 90. Then for inside profile we are having height of 85. For this we need height of 85. Next to that, from this point to this end we are having vertically 5 mm. Dimension from this point to this point, this vertically we are having here 5. Done. Then just we will create one center line, one vertical line exactly from origin to this like this. Then exit sketch, make it isometric. With this shape we need to add material with rotation along with the center line. We can go here with the revolve bus. Center line is this. Let's say OK. So this outer part will be created. Then next to that, we need to remove material with this radius 40 curve. So for that, I will go for front plane sketch. Here I am going to create one 3-point arc like this. Then by using line, just I will convert this arc into a closed profile by drawing these extra lines. Then relation between this point to this origin, we need here vertical relation. Then relation between line to line, we need here equal relation. Then dimension for this we are having radius of 40. Then this height we are having 12. This line height we need here 12. Dimension from this end to this end horizontally we are having here 50. So this line dimension we are having length of 50. As you can see, sketch is fully defined. Make it exit sketch, isometric. With that we need to remove material. We can go for extruded cut, blind with mid plane. Material should be removed up to end. Just make it like this. Material will be removed properly. Then next to that, we are having one circle here with a diameter of 40 here. They have not specified diameter. We will consider as diameter 40. Material should be added with a distance of 38 by 2, 19 up to next. It means now this profile is on front plane. That cylinder should be on this right plane. We will go for sketch. Make it normal. Just we will create one circle here with diameter of 40. Then this point to this origin point we need vertical relation. As you can see, Dimension from this point to this we are having vertically 27. From this to this we need vertically 27. Exit sketch, isometric. Now if I go for extruded boss, up to next, material is going to start exactly at center, but we need to start with a distance of 19. So in this case, here from option will be there. We can open that. We can go here with offset. Offset distance of 19 we want, means with reference to this sketch, with offset distance of 19, from there it will start, up to next it will add. Now same boss extrude we need this side, we can make it mirror with reference to this right plane. Let's say okay, like this. Then next to that we will create this ring parts. So for that I'll go for sketch on this front plane, make it normal. Now we need one rectangle here like this. Then add relation between this line to this point we need here coincident. It should be exactly straight to that. Dimension for this line we are having here, as you can see, this width we need 4.3. Then dimension from this point to this end line we are having 11.6. From this point to this end we are having here 11.6. Then inside diameter we are having here 79 for that pockets. So from this origin to this inside line we are having 79 by 2 like this. That exit sketch, make it isometric. Now with this shape we need to remove material with rotation. To remove material with rotation we need one central axis. Already we are having one cylinder here. In that case we can go for hide or show items. You can show this temporary axis, just turn on that. Now go here with revolve cut with reference to the central axis. Let's say okay. So with reference to that center axis material will be removed. Now same this cutout we are having total 3. So this cut revolve we will go for pattern with reference to this cylinder. Total we need 3 with a distance of 4.3 plus this width we are having 7.3. So we need to give here 4.3 plus 7.3. Let's say okay. So properly that 3 cutouts will be created like this. Then at end we are having here, as you can see, center we are having one hole with a diameter of 33.8. Then just we'll go with this 33.8. So for that we need to create one hole here. We'll go for hole wizard. Here we are going to use legacy hole with simple hole diameter of, as you can see, 33.8 we want. 33.8. Depth up to next. Position exactly on this face, that too on this exactly at center point of this. Let's keep it there and say okay. Now same hole we need this side also. Just we can make it mirror with reference to this right plane. Let's say okay. Now at end if you want to hide all these axis systems, just you can turn on this, it will be hidden. If you make cut section with reference to this and say okay, by using Ctrl+1 I'll keep it front view, we can cross check this properly. So in this way we need to create this piston. So just we will apply some color for this by using this appearance. We will apply some color for this part and we will save it. Now let's create this connecting rod in SolidWorks. So just we will enter into here new part. Now to create this connecting rod, first I am going to start with this shape on top plane. So on the top plane we'll go for sketch. We need here center point straight slot like this. Dimension for this we are having radius of 9 and length of 76. Exit sketch. Go for features. Make it isometric. We need to make this extruded boss of height 30. Let's give this height 30 and let's say okay. Next to that with radius of 27. With this curve we need to remove material. So we'll go for sketch on this front face, make it normal. By using center point arc, just we'll create one arc like this. And to make it a closed profile, we'll draw one line from end to end point. Then dimension for this we are having radius of 27. Exit sketch, make it isometric. We'll make it here extrude cut up to next. Let's say okay, like this. Then next to that we are having here double curves, and with these two circles we are having material with width of 38. Now again we'll go for sketch on front plane, make it normal. To create this closed profile, just we will go for convert entitles for this inside curve. Let's say okay. One more curve we want outside with a distance of 36. So if we make 36 minus 27, we will get this gap of 9 mm. Directly we can use here offset entitles for this with a distance of 9. Let's say okay. Now to make closed profile, just we will close it with a line. Again from this to this one line. Then along with that we are having here two circles. So just we will create two circles here. Dimension for outer one we are having diameter of 48. For inner one we are having 33.8. Then add relation. This point to origin point we need vertical relation. Let's make it vertical. Dimension from this origin point to this point, as you can see vertically we are having here 201.2. So just we'll give 201.2. Then exit sketch, make it isometric. Extrude boss by using mid plane. Total width we are having here 38. So let's give this width of 38 and say okay. Next to that we need to create this center part with width of 18 exactly from center. So again we will go for sketch on front plane, make it normal. Now to create this shape, just we will convert entitles for this outer circle, then this one more curvature. Let's say okay. Now we need one line exactly from this circle to this circle. Now same line we need this side, so to make it mirror, just we will create one vertical construction line like this. Mirror entitles, I need to mirror this with reference to this. Let's say okay. Then we are having here dimension from point to point. Horizontally we are having 20. So this point to this point, horizontally we are having here 20. Then angle between line to line we are having here 6 degrees. So line to line we are having inclination of 6 degrees. Then next to that, as you can see here, one curve is there with radius of 40 tangent to this and tangent to this line. So let me create here one 3-point arc from this line to this curvature in this direction. Add relation between line to curve, we need tangent. Clear selection, curve to this curve, we need tangent. Let's say okay. Dimension for this we are having radius of 40. Let's make it 40. Now same curve we need this side, we'll make it mirror with reference to this. Let's say okay. Let's go for trim and trim this unwanted elements. Just trim this unwanted elements here. Then this profile also we don't want. Then exit sketch, make it isometric. With this shape we need to add material by using mid plane with a total width of only 18. Let's give here width of 18 like this. Let's say okay. Then we will go here with this removal of material with this shape with a depth of 4 mm on both sides. Now on this face we will go for sketch, make it normal. Just we will create one straight slot like this. Dimension for slot, as you can see, radius is 8, length we are having 90. So this radius we are having 8 and this length we are having here 90. Then to make that proper position, we don't have any proper dimensions here. So just we will take dimension from this to this. We'll keep it here some 65. Exit sketch, isometric, extrude cut with a depth of only 4 mm. Let's say OK. Same this extrude cut we need in reverse direction. We'll make it mirror with a reference to this front plane. Let's say OK. Like this, on both directions we need to remove material with that slot shape. Then later to that we will go here with fillet of 22.5. So 22.5 of fillet we need for this edge and this edge with radius of 22.5. Let's say OK. Then next to that, as you can see here, radius of 3 mm we are having for this part. So just we will apply here radius of 3 for this. Here, then this side we need only here radius of 3. Let's say OK. Then entire thing we have given here, all details and all parameters we have given. At end we are having here diameter of 9, 2 holes are there. So just we'll create that 2 holes. Again one more radius of 1 mm we are having inside edge. So fillet for this inside one. Again this inside edge we are having here only with radius of 1 mm. Let's say OK. Then at end we will go here with creation of holes with a diameter of 9. So let's go for hole wizard, legacy hole with a diameter of 9. Depth should be up to next. Position is exactly on this face. With reference to this curvature, we need exactly at center point. Same here also, with reference to curvature, we need exactly at center point. Let's say OK. So like this we can create this connecting rod. So just we will apply some color for this. Just we'll give some different color like this. Then save it. So in this way we can create this connecting rod. Now let's create this connecting rod cap. So just we will enter into here new part. Let's say OK. Now to create this, we are going to create this profile first. First I will go for top plane sketch. By using this center point straight slot, just I will create this shape. Then dimension for this we are having radius of 9 with a length of 76. Radius of 9 with a length of 76. Exit sketch, make it isometric, extrude boss. So total height we need here 60. Let's give height of 60 here. Let's say OK. Then next to that we are going to remove with this circle shape and again this shape also. Now on the front plane again we'll go for sketch, make it normal. We need one center point arc exactly from this horizontal to horizontal and we'll create one line from this point to point. So we need dimension for this inner curve with radius of 27 like this. Then this riv also we need to remove material. Just we'll go for line. I'll create this shape like this. Then dimension for this, vertically we are having 22, horizontally we are having 27. This is vertically 22, horizontally we are having 27 like this. Then same profile we need this side. So to make that mirror, just we'll create one center vertical line for construction purpose like this. Then mirror entitles this entire part we need to make mirror with reference to this one. Let's say OK. Exit sketch, make it isometric. We'll go here with extruded cut by using mid plane on both the directions, and let's say okay like this. Then next to that, as you can see here, double curves we are having with a total width of 38. So exactly on front plane, again we will go for sketch. Instead of drawing the circle again, select that, convert entitles. Then same curve we need one more with gap of inner one we are having 27, outer one we are having here 36. So gap we are having here 9 mm. We will go for offset entitles for this with gap of 9. Let's say okay. To make it closed profile, just we'll create one line from this to this, one more line from this to this, then exit sketch, make it isometric, extrude boss by using this mid plane. Total this width we are having here 38. Let's give this width of 38 and let's say okay like this. Then next to that we are having here fillets with radius of 10 mm. Let's apply that radius of 10 mm fillets. Fillet we need exactly for this edge and this edge with radius of 10. Let's say okay. Then one more we are having here, as you can see, this edge we are having with radius of 3. Fillet we are having for this external edge, this edge and this edge with radius of only 3 mm. Let's say okay like this. Then at the end we are having here two holes, one with a diameter of 9. Same here also we need one more. Now let's go for hole wizard. Legacy hole with a diameter of 9. Depth should be up to next. Position we need exactly on this face. That too exactly on that center point. If you go on curvature, it will highlight point. One click here. Same this side also. Exactly center of this. Here one click. Let's say okay. Like this we can create this connecting rod cap. So just we'll apply some color for this and we will save it. Appearance. Just we'll give some color. Okay. Save it. Let's create this piston pin now. So to create piston pin, we are having piston pin diameter of 33.8. It should be make extrude bus of 82. Then at these two edges we are having chamfer of 2 mm. So just we'll go here with new part. Let's say okay. So for example on this right plane I'll go for sketch. We are having one circle here. Diameter for this we are having 33.8. Exit sketch, extrude boss. We are having extrude boss of 82. Let me give this length of 82. Then chamfer of 2 mm for both edges. So chamfer we need for this to this with length of 2 mm with inclination of 45 degrees. Let's say okay. Then just we will apply some color for this by going with appearance. So let me apply some color. Then we will save this. So here we need this piston pin. Just I'll specify name of the part, piston pin, save it. Then along with this we need to create this piston ring. So let me go for new part. For example on the front plane we'll go for sketch. We are having here two circles 79 and 85. So just we'll create two circles. For inner one we are having here 79. For outer one we are having here 85. Then extrude boss, it should be made with thickness of 4.3. So just we'll give this thickness of 4.3. Let's say okay. Then just we'll apply some color for this. Okay, we will save this. So here we need this one as piston ring. So just we'll make it as piston ring and we will save it here. So in next video we are going to do this assembly design of engine assembly. Now before going to create this entire assembly design, first we'll go here with sub-assembly between this connecting rod cap, then again this piston and piston rings are there, along with that piston pin also there. So let me create this sub-assembly first. So just we'll enter into new assembly design. Let's say okay. So first I will call this connecting rod open. Just we'll keep it somewhere here. Then next to that, as you can see here, this part it is showing as F. F is nothing but fixed part. But if I go here with visibility and if I turn on view origins, we are having different origin points. It means this origin is related to this part design. This it is related to assembly design. So always these two origins should be at same point. So in that case, we can make it here float this part, and if we try to move freely it will move now. Then we will apply relation by using mate between this origin to origin. We will apply here coincident. Let's say okay. Now this part is fixed. If we try to move it won't move. Then next to that, insert component, we will insert here connecting rod cap. So just to change orientation I'll use with reference to Z axis. I'll keep it here. To apply relation we'll go for mate between this hole to hole, we need concentric. Just I'll drag this hole to this hole, we need also concentric. Then this face it should attach with this face. So just we'll say it okay and say okay here, make it isometric. Then next to that again we'll go for insert component. We will insert here piston. Just we'll keep it somewhere here. Then we need to apply relation between this circle to this circle. We need concentric relation. Let's say okay. Then inside this face it should attach with this face. We'll make it here coincident relation. Let's say okay. Then next to that, insert component, we will insert here piston pin. Let me open piston pin. Then mate between this to this. Let's say okay. Then if we try to drag, it is able to move in this direction. Now this pin should be inserted exactly at center. So in these conditions, we can go here with advanced mates. We can use here width option. So we need to insert this pin between any two faces. So let me select this face and this face. It should be inserted between this face to this face. If I select here properly, it will come at center. Let's say okay. Then for this pin, if we try to move, we are having here degrees of freedom with reference to rotation. So to lock rotation, again we can go for mate. As you can see, we need to lock rotation for piston pin. So just I will select any plane like this. So that plane, it should be exactly parallel to this plane. Let me make it parallelism and let's say okay. Now if we check here, degrees of freedom is fixed for this particular piston pin. As you can see, if any part is like not fixed properly, it will show here minus. Now this piston is not fixed because rotation is there. So we need this rotation. So that's why we have left like that. Then next to that insert component, we will insert here piston ring. Let me keep it somewhere here. Relation between, so this cylinder to this one, we need here concentric. Let's say okay. Then this face, it should attach with this face. Then make it here okay, coincident. Same here also for piston ring, we'll be having rotation. So to lock that rotation, piston ring I'll open. I'll select this side plane. So for that, I'll make it parallel to this face. So just I will delete this. Why? Because this is an inclined face. We'll select flat face. Then we'll make it here parallelism. Okay. Now piston ring also fixed. Then same here, piston ring, we need here 3 times. So instead of calling again insert component and applying relations, directly we can go one option called copy with mates. Select component, we need to copy with this piston ring, then go here with the next option. So we need to apply relations. Concentric relation we need for this cylinder, as it is highlighting in orange, just select that. Then coincident we need, before we have given for this phase, now we want for this phase, exactly for this. Then parallelism we need for this phase. Let's say okay. Here one more ring is created. Same like that, one more concentric to this, we need to attach with this face, then parallel to this face. Okay, so already 3 rings inserted. At end we can close this. So like this we can create this sub-assembly. So if you want to hide all these origin systems and all, just we can click on visibility, properly sub-assembly will be created. So just I will save it as sub-assembly. So sub-assembly of engine, which is consist of connecting rod cap, again piston ring, piston and piston pin. Let me save here. Before we have created this separate sub-assemblies, so now we will create this main assembly design. So to create main assembly design and to give simulation for this particular crankshaft, we need one central axis. For that, let me create one new part. On the right plane, I will create one line like this. Only for reference purpose, we need this line. So we will save this. So just we will save it as part 1. Now just we will close this. We will go here with new assembly design. Open that. So first part I will call this reference line like this. Now as you can see here, this one already it is fixed. But once if I go on visibility and I click on origins, so 2 origins we are getting. This origin is related to this part design. This origin is related to assembly design. Always these 2 origins should be with reference to same point. For that, we can float this part. Then this part will be moving freely. So to apply relation, we'll go for mate. We'll apply relation between origin to origin coincident. Let's say okay. Then insert component. We will insert here crankshaft. And to change this orientation, we need to change with reference to y-axis like this. Then relation between this line to this cylinder, we need here concentric relation. Let's say okay. Now this part, it is able to move in this direction. So to lock that movement, we can select this face. It should get attached with this front plane. Let's say okay. Now this part it won't move in this direction, but it is able to rotate in this direction. So for simulation we need this rotation, so that's why we are not going to fix this rotation. So just we'll adjust proper orientation by using front view. Then insert component, we will insert here connecting rod subassembly. So subassembly of connecting rod, let me open that. Just I'll click here, then I'll turn off origins. Now relation we need between this to this, we'll make it here concentric. Let's say okay. Just I'll drag this out. Then exactly this entire assembly, it should be fit in between these 2 faces. In that condition, we can go for advanced mates width between this face to this face. It should be exactly inserted between this face to this face. Properly it will come at center in between these 2 faces. Let's say okay. Just we'll make it here Ctrl+1 to keep it front view, and we'll adjust this orientation properly like this, isometric. Then next to that, we are going to call here new subassembly design of this piston. So insert component, subassembly of piston. Let me open that. We'll keep it somewhere here. Then we need to apply relation between this cylinder to this cylinder. We'll make it here concentric. Let's say okay. Then next to that, we are going to apply some different relations here. So this piston assembly, exactly it should be center of this thing. So same as we have used earlier, we can go here with width option. So we need width between this face to this face. It should be exactly center of this face to this face. So properly it will come at center like this. Then as you can see, if I try to move now, so if I click on control plus 1, this piston assembly's position is not proper. So what we required here, this piston should be able to move only in up and down direction. So in these conditions, just we will show here this temporary axis. Now we are able to get axis for this piston assembly. We'll apply relation between this axis to, we will select here this right plane. Properly that axis it will come straight to that right plane. Let's say okay. Now just I'll turn off this. If I keep it on front view by using control plus 1, if I rotate this, this will be rotating. Piston will move only in linear direction, up and down movement like this. Isometric. Now whatever we have applied this connecting rod assembly and piston assembly, same we need to repeat all these places. So if you want from here, you can just forward that video, or else you can increase the speed of the video. Now let me make same the sub assemblies here. So instead of calling insert component and making separate sub assemblies, directly we can use one option called copy with mates. So let me go with this assembly first, connecting rod assembly. So just we can open here. We need this sub assembly of connecting rod. Let's go here with the next. First we have applied concentric to this. Then width between this face to this face we wanted. Then next to that we need concentric between these two. So let me select this. So just we will click here. I will make this cylinder selection. Now same the sub assemblies, we need to insert all these conditions. So instead of going for insert component and inserting again and again, we can go here with copy with mates. We need to copy with mates of subassembly of connecting rod and subassembly of piston. Let's go for next. We need concentric relation for this. Then width between this face to this face like this. Then next to that, coincident we need with reference to this front plane. This right plane I'll select. Let's say okay. Now same again we need to repeat same subassembly for this cylinder. Width we need between this face to this face, then parallel to this right plane. Let's say okay. Again here also we need concentric to this, width between this face to this face, then coincide to exactly with reference to this right plane. Let's say okay. At end we will cancel this. Now as you can see, properly these sub assemblies were assembled to the main assembly. If I click on front view by using control plus 1, and if we try to rotate this, proper orientation we have achieved now. So now we will go here with simulation. So simple, in a simple method we can apply this simulation. For that, let me keep it in isometric view, and here it is showing to make it rebuild. It is nothing but update. We can click here for rebuild. Then to make it simulation, just we'll go here with motion study. So we need to apply some motor here. So to apply motor, we can click on motor. Here two type of motors we are having. One is rotary motor and one more is linear motor. We need here rotation. So just we will go for rotary motor for this shaft. Either we want rotation in this clockwise or anti-clockwise. We can change by using this reverse direction. So let it be in this direction. Then speed we can adjust here. Let it be 100 rpm and let's say OK. Then next to that, we need to adjust frames per second for visual display properly. We can go here with this motion study properties. Frames per second, we will keep it some 60 here. Let's say OK. Now, if I click on calculate here, just it will calculate whatever the parameters we have assigned for that particular assembly to make it simulation. Let it calculate first. Then next to that, we can increase or we can decrease the speed of that motion simulation. For example, I'll keep here 0.25 like slow. Then we are able to change different orientations here. Like normal means only in one direction from starting to ending it will come. If you make it loop mode, again and again same step will be repeated. Again reciprocate means first it will go in clockwise, next it will come in anti-clockwise direction. Now for this one, we will make it here loop mode. Just we will click on this play from start. So you can see proper orientation of that particular simulation of this engine assembly. So in this way, we can create this assembly design and we can make it simulation like this. So let it complete here. As we have kept here loop mode, again and again it will be continuously repeating the same process like this. Now if you want to stop that, just we can stop here. Then just I'll adjust to starting. If you want to save this animation, just we can go here with save animation and we can save this. Or else just you can minimize the screen and again you can play from start. Proper simulation will be able to see here. So just I will stop here, then I'll adjust here. I'll make here save animation. So we need to save that in which format we want. We are able to select here. So just I'll click on here MP4 video format and just I will make it here save. Only simulation will be saved in MP4 format. So just it is going now preview. So once if it is done, video will be saved onto our local files. So in this way, we can save this animation videos also. Now let me check how it is saved. So for that, just I'll go for files. So we have saved under this engine. So MP4 video is available here. Just let me play that. Proper animation we are able to see like this. Thanks for watching. Keep supporting